Hi, this is Professor Stuckard, and in this video we're going to go over some of the basics of vectors. So, the goals for this video, basically we just want to understand what a vector is, and then we're going to learn how to add vectors and multiply vectors by scalars. So, you may already know how to do this, and if so, feel free to skip this or kind of skim through it quickly, but we're really going to have to understand the mathematics behind vectors from the get-go to understand how we're going to use the math of machine learning in this course. So, but what is a vector? Well, a vector is a one-dimensional data structure, very similar to kind of an ordered list. And a vector is then composed of, well, multiple data values. So it's a one-dimensional structure. Again, it's only got one set of values to it. It's that kind of ordered list, but obviously it's a list, which means it has multiple data values in it. And we talked about vectors in data science because we considered our data frames to be composed of multiple vectors, where each variable or column was stored as a vector. Now, again, that is absolutely a vector structure. What we're going to really talk about in this video, though, is more of vectors as mathematical objects and vectors that only contain numerical data, or what we call scalars. And scalars is just a word that we use to describe a single quantity or number used to typically denote size or scale. So like the number 2, that's a scalar because it's just a number by itself. Or the number 1,000,000, that's a scalar. It's just a size or quantity. And again, we can use it to represent one thing. So we could say we have $1,000,000 or $2. So we can include units with them too. Vectors are when we take those scalars and combine them into that ordered list or that data structure. So there are multiple ways that we represent vectors. When we name vectors in math, we typically put an arrow over the top of it because when we talk about vectors, we typically talk about them in the context of mathematics or physics as having a magnitude or a size and a direction. The other way we denote them is writing it in bold. I would typically not recommend doing bold because it's very hard to write in bold. It's much easier to put that little arrow over top so you don't get confused. But you'll also notice that, again, in most of the context we're going to be using with programming languages, we're going to define our vector as some sort of variable name in our code. This is, again, very mathematical way of doing it. So let's say we have a vector composed of the two scalars 4 and 3. How do we actually write that out? Well, we're typically going to write that in kind of our matrix style here, where we use square brackets, and we're going to have the 4, then the 3 as that ordered list vertical. Again, thinking of these in terms of really columns. And yeah, this is the typical way we write them in terms of computer science and linear algebra. If you've taken physics courses or maybe even multivariable calculus already, you'll see we sometimes put them inside of triangle brackets and listed in order, kind of left to right. We're not going to really see that at all in this course for the most part, but it does exist. And then, of course, there's also the physics and the geometrical meaning where, like I said, scalars have a magnitude and a direction, and so the vector 4, 3 points to the ordered pair 4, 3 in my two-dimensional coordinate plane. And so again, we represent that as an arrow. All of these are valid. All of these are still describing the same exact data structure. It's just different ways to think about them, different contexts that we can use them, which is really what math is. Math is really how do we kind of represent the same idea in different contexts. And they all have their individual uses. But like I said, typically we're just doing things with computer science and linear algebra. So what do we actually need to do for vectors mathematically? How are we going to be using them? Well, the first thing is just vector addition, and you're going to see the mathematics behind this is actually pretty simple. So to add two vectors, you add their corresponding component. So I have my two vectors here. My first vector is at 3, -1, -2. My second vector is 5, 7, -5. If I want to add them, again, we go by components. So look at those first two components. The top one's a 3 and the 5. We add 3 plus 5, we get 8. That becomes the new first component of my resultant vector, or of my answer. And we just do the same thing with the other ones. -1 plus 7 is 6. -2 plus -5 is -7. And that's it. That's how we add vectors. Add their corresponding components. It's really that simple. The other one we want to look at is scalar multiplication. And to multiply a vector by a scalar, basically we're scaling it up in size, and all we do mathematically is you just multiply each component of the vector by that scalar. So my scalar in this problem is the scalar 5, and then my vector is that vector composed of the values 3, -2, or 3, -1, -2. And again, to multiply, you just multiply each of those individual numbers by 5. So 5 times 3 is 15, 5 times -1 is -5, 5 times -2 is -10, and well, that's it. Scalar multiplication is just that easy. You scaled it up. And so in this case, our new vector is 5 times bigger than our original vector. And that's this term scalar. We're scaling it. So that's it. Can you perform the following vector arithmetic? Can you add these two vectors? And then can you do that scalar multiplication as well? And that's really all I wanted to do with this video. So hopefully that was pretty straightforward. We understand how to do that now. As always, if you have any questions, let me know. But otherwise, well, good luck.